Hi friends, welcome to my live stream. In this live stream, I will teach you about connection design in IDEAstatica. How we create the geometry of the structure, geometry of connection, and how we apply the load. Okay, so this is uh, with respect to IS code or with respect to ASC code. First I will teach you about with respect to IS code. Okay, in IS code there are uh, we will uh, take one example of base plate connection. Okay, and in that base plate connection with different type of loading we apply and different type of connection we can uh, design. Okay, so first go with this ideas. uh, Suppose this is your beam. This is your beam geometry. Okay, in this geometry you want to analyze and design with respect to here also your one beam is available. So for that what we do, just a wait. So in this, okay, so just I am teach you, this is your beam column connection. Okay, so if you want to create the other beam also in this structure, in this connection, then you can add with respect to this member. Okay, I want to create other beam in that direction, so create on beam just new member. Okay, this member is perpendicular to this, just provide a beta angle pitch. Okay, see this beta angle 90 degree. Okay, so you can see there is other beam created here, and also I want other beam here also. So just new member, and after new member is minus 90. Okay, so here you can see there are three beams is created. So I'm just delete this stiffeners and cut everything in this connection. So I'm just adding from here operation, I want connection design like this: end plate, beam to column or beam. Okay, just select the bolt size and bolt grade. I want I'm go with 8.8. Okay, just select that, and for I'm just give this connection to this B. So here this member B and connected to C, and you can see here this connection created here. And for just like this, create other operation also. End plate, this connection is for member M4. You can see here M4 is created, and then you can just create new operation, create beam, and this is for M3. Just create for M3. So this all connection is created. Okay, after your modeling is completed, you want to check the bolt. Okay, what type of bolt you want, which bolt means the number of bolt you want, 2, 4, 8. Just decide, and accordingly you can analyze. I want to go with 2 bolts. Minus 45 minus 40. Okay, I want only 2 bolts, and you can see here plan view. Okay, just like this. For B, we can change from here minus 25. Two bolts are created. Just go into this and just changes. Okay, now our connection is modeling is completed. Now second point, load effect. You can see here loading is assigned here. For M3 we want for 50. Okay, minus 50, and this for minus 60, and moment in these joints 15, 25 and 20. Okay, these moments are coming on this structure, and this 15, 55 and 60. So just after completing all the modeling, loading and operation, then the second point is to calculate. Just click on calculate, you get the result. Okay, so after this completing, this take time. Okay, for designing this take time, but after designing, software give us the detail of our connection is pass or failing. Now you can see our connection is failing. Okay, the plate will come very high ratios. So because of that, the plate, bolt and bolts are fail. Just go in operation, click on member, then increase the thickness of plate and increase the bolt flange weld to 8 mm, and this is 6 mm. Increase the bolt size. I want go with 16 mm bolt size with 8.8 grade. Say just like 18 mm, and this is 8 mm, this is 6 mm. Okay, bolt is 16 mm. Third one is 18 mm, 18 mm, and the bolt is 16 mm, and this is 8 mm, 6 mm. Just now calculate, you can get the result. If you don't get anything from any missing from here, member load effect, you can add from here. Okay, this is, you can see in design box, you can see this member load operation also here. If anything is not coming here, then you can add from here. Okay, now you can see the ratio is decreasing, but what happened to our member? Okay, just a wait. Now you can see uh, the load is applied from our side is more, so we can reduce that to minus 30, minus 30, and minus 20, and this is 30, 25, and this is 25, 20, and this is 3, 5, 8, 10, and 5, 8, 7. Just calculate this. Because of our loading is more, so because of that structure is fail. We get the plate is failing now. The plate is failing and the bolt is failing. So what we do, just increase the bolt, number of bolt. We want to increase the number of bolt. Okay, for number increase the number of bolt, you can see here minus 45 to minus 50 for B member. just like that we can add -50 to everyone, because our connection is failing under bolt also. -50 and minus 50. Now we can calculate. Now increase the plate size to 22 mm. This is also 22 mm and this is also 22 mm. So you can see the upper bolt in this diagram. Upper bolt is fail. For that we can, okay, this is the moment is very high. Okay, column moment is very high, so because of that is happening. Now we can increase the bolt size and bolt grade. Okay, I'm just go with 450, 540 for all the same. I want to just increase the bolt grade. After increasing the bolt grade, there is nothing should be nothing happen in the structure. Okay, 20 mm bolt. Now we use 20 mm bolts. And increase the weld size. No, I think this should be less. 6 mm is sufficient. Because if the wind is more, then the difficulty create in the connection of bolted. It will create difficulties for connection bolted. Sufficient. What I am do, I am just decrease the Okay, detailing is problem creating detailing. Minus 44 minus 55, member M3. Minus 55 minus 45 minus 45, and the weld is 8 mm. Okay, the weld is more, because of that our connection fail in detailing. Because of weld we take more. Just reduce the weld size. This is very important. We can maintain equilibrium in bolted and bolting and welding. If we don't create equilibrium, then the structure is fail. Minus 30, and this is also minus 30. Minus 30 minus 30. The end distance, edge distance, edge distance important for our connection design. So this connection design is pass. You can you can see here buckling is not calculated, and you can see here different types of analysis type here is shown. You can see stress strain. If you want to design for stress strain, then we can by default software automatically calculate for stress strain. But if you want for others like stiffness, then you can click on this also. So if we click on stiffness, then they calculate for stiffness. Stiffness of connection. What is the stiffness of the connection? Software calculate accordingly. Whatever you want, just add the analysis type. Accordingly, the software gives us the result. Okay, you can see here the stiffness is in stiffness the structure is connection is pass. So just click on the stress and come into the check parameter check tab. Just click on stress strain or buckling. Just click on this. Then software give us buckling result also. So you can see here stress strain. Just wait a minute. Just add. So what is the problem? Before this this connection is passed, but now this connection is failed. I don't know what is happening. Flange bend 8 mm. 8 mm. 8 mm. Okay, welding is pass. Now go with bolt. Just first focus on plate 26 mm, 26 mm, 26 mm. Now calculate. You can see here different type of gamma m0, gamma m1 here. Okay, accordingly whatever your plate bolt is failing, you can calculate. And if you want to check for the buckling also, you can check from here, stress strain or buckling. And if you want bolt forces, then you can check from here. This is bolt force. Okay, this is bolt force, you can check from here. Or meshing is here. And if you want to deformation shape, then this is deformation shape. This is equivalent stress diagram. Okay, you can see here equivalent stress diagram. Or for extreme, for current, you can see there are two different conditions, extreme or current. Or you can check for overall check, you can also check. And strain check, if you want strain check, then you can get this. If you want to check for buckling analysis, buckling shape, this type of buckling shape you can get. And okay, all these are importance. And the other check you can get from here, this plate checks. Okay, in this which plate is failing. And you can see here the thickness of plate. For if you click for bolt, which bolt is failing, here you can see status. In status you can see why this failing. This fail in interaction of tension and shear check. For interaction and for interaction of tension and shear check, you can check the thickness of plate. Thickness of plate is less, so because of that our section is failing. So this is very important criteria to check why our structure is failing, or what we do for that. Okay, here in welding you can see here our weld is passed, so there is no fail item in welding. In buckling you can see here different type of buckling are present here according to load effect. And plate, this plate is failing, so this is plate. So this plate is for weld. So our column weight is not sufficient to carry this load. Because of that our connection is failing. So just redesign that column and increase the column web thickness to get accurate and economical connection design. If anyone have any doubt and difficulty, please ask me, so I will solve here. Comment me in live chat, so I will clear that doubt in live. Hmm. Second one, this is column beam connection. In this lecture, we will see about the column connection design. But what about other connections like base plate connections? So just go into the project and new the base plate connection I want to design. Just click on moment connection, create project. Okay, after creating project, then you can see there are different shapes and already default connection create here. This is for stress, strain, stiffness, capacity design, joint design, fatigue, fire resistance. Base plate. In base plate, you can see the washer plate, circular washer plate, rectangular is here. We want for straight. In some will type change. Okay, just calculate. So the anchor is not calculated in IS code, and buckling is calculated. Just go into the check parameter, and here you can see buckling parameter is also given here. So the structure calculate, buckling also calculated. In IS code there is a limitation, so because of that anchor is not calculated here. So for that, for the connection design, for the anchor design, you just go into the bolt forces. Okay, so if you click on the bolt forces, then you can get the bolt forces diagram. There are 4 bolt here. You can see there are different load coming on that bolt. A3, A4 doesn't care, doesn't get any loads. Okay. Here you can see the welding is calculated, concrete block, buckling, and analysis. So all the things are correct. So this is for base plate design. Likewise, you can see there are different option is available like buckling check. For column, buckling check is very important. So the buckling shape come like this, and your This flange member carry the maximum load. Okay, from this side the that flange is doesn't get any load, but these flange carry the maximum load. For strength check, overall check, and concrete block, different types of stresses will come into the structure. Now this is a report. This is a tab for report generation. So if you have come any doubt and difficulty, please ask me. This lecture is about to finish now. We will meet in suitable time. Okay.